Perceiving the similarity between images has been a long-standing and fundamental problem underlying various visual generation tasks. Multifarious image generation tasks often entail multifaceted metrics to measure the inter-image similarity with regard to different properties such as image structures, image semantics, and image perceptual realism, etc. Defining generic metrics to fulfill multiple objectives is challenging as different visual properties are usually entangled in pixels and the notion of visual similarity is often subjective. Image similarity measurement remains a very open research challenge in visual generation tasks. Predominant approaches measure the inter-image distance by computing pointwise absolute deviations, which tends to estimate the median of instance distributions and leads to blurs and artifacts in the generated images. In this work, we formulate contrastive learning as a versatile metric for various image translation tasks. In unpaired image translation, contrastive learning allows to preserve image contents by maximizing the mutual information of corresponding patches. In paired image translation, contrastive learning is employed to measure the perceptual similarity between images in line with human judgment, by leveraging pre-trained networks for feature extraction. However, vanilla contrastive objective repels all negative samples indiscriminately, which is apparently suboptimal as negative samples usually have different similarity with the anchor. Certain weighting strategy is desired to formulate more effective contrast by adaptively adjusting the pushing force of negative samples, aiming to boost the translation performance. We comprehensively investigated different weighting strategies for negative samples and some non-trivial conclusions are drawn for the selection of weighting strategies in different scenarios. Intuitively, hard negative samples with high similarity to the anchor should be assigned higher weights, complying with the rationale of hard negative sampling. It is true for unpaired image translation where negative samples can be easily pushed apart, as illustrated in the similarity distributions of negative and positive pairs. However, for paired image translation, negative samples are hard to be pushed apart from the anchor or positive pairs as there is severe overlap for the similarity distribution of negative and positive pairs. In this scenario, we surprisingly find that the intuitive hard weighting strategy tends to impair the performance, and an inverse weighting strategy allows to improve the performance. In addition, as in patch NCE loss, contrastive learning for measuring image similarity involves several sub-objectives as each image patch is associated with a contrastive objective. Reweighting each sub-objective separately without overall coordination tends to be suboptimal. We propose to employ optimal transport to modulate the reweighting of all negative samples collaboratively across the multiple objectives, with a cost matrix designed based on the similarity of negative pairs. Optimal transport allows to retrieve an optimal transport plan which serves as the weights for negative samples to reach an overall optimal objective. We evaluate our proposed loss on the classical unpaired image translation task. We first adopt the model structure of cut to conduct comparison between different losses. The weighting strategy of assigning higher weights to hard negative samples is adopted for unpaired image translation. For paired image translation, we adopt the structure of spade to perform the comparison. Extensive experiments over multiple image translation tasks show that the proposed modulated NCE outperforms various prevailing metrics substantially. Our thorough and extensive analysis of negative pair weighting strategies lays a sound foundation for the exploration of contrastive learning in image generation.